All right, so today we're going to talk about solving exponentials and log equations, and that's what you're going to learn, how to solve them. All right, so we're going to have a couple of different cases. The first is going to be when we can make the powers have the same base. Once they have the same base, all you have to do is set the exponents equal and then solve. So in this case, we have 3 to the 2x and we have 27. 3 to the 2x is equal to, and we know that 27 is 3 to the third power, so equal to 3 cubed. Okay, and now we can just, since the bases are the same, set the exponents equal, and we get 2x equals 3, and dividing by 2, x equals 3 halves. And that's all there is to that. Okay. In this case, we've got 16 and 1/64 as the base. So 16 can be written as 4 squared, and then we're going to multiply it to the exponent that we have. And then 64 can be written as 4 cubed, but this is 4 to the negative third because it is in the denominator. So now all I have to do is set my exponents equal to each other. So I'm going to get 2 times 3p minus 1 equals negative 3 times p minus 2. Now we used the exponent rule that said that when we take a power to a power, we multiply. So that would be x to the 6. So that's basically the property that we used. So if I distribute, I get 6p minus 2 equal to negative 3p plus 6. If I add 3p to both sides, I'm going to get 9p minus 2 equals 6. If I add 2, I'm going to get 9p equals 8. And divided by 9, p is going to equal 8/9. Now sometimes they're going to have the different bases, and we can't do it that way. We have to use logs to solve. So what we're going to do is, before we take the logs of both sides, we're going to get the term with the exponent by itself, so that I'm going to get negative 3 to the x equals, if I subtract 5, negative 45. And then I'm going to divide by a negative, so I get 3 to the x equals positive 45. And now I'm going to take the logs of both sides, so I get log 3 to the x equals log 45. And then we're going to use the property of log that says that that exponent comes out in front so that you multiply, so you get x log 3 equals log of 45, and then divide both sides by the log of 3. And then you've got to use your calculator to do that. And so the log of 45 divided by the log of 3 is approximately 3.465. Right, let's try another. Right. So now we've got with the exponent all by itself, so we can write as log 2 to the 3x minus 4 equals log 5. We're going to bring that out in front, so we get 3x minus 4 times the log of 2 equals log 5. Going to divide both sides by the log of 2. And I'm going to get 3x minus 4 equals log 5 divided by log 2 is approximately 2.323, or 22, sorry. And then I'm going to solve like I would a normal equation. I'm going to add 4 to both sides. So I get 3x equals 6.322. And then I'm going to divide by 3 so that x equals approximately 2.107. Right, now when solving log equations, we're going to write them in exponential form. So remember, when there's no base, we assume it's 10. So when we switch it, this is 10 to the negative 1 equals 2x. And 10 to the negative 1 is 1/10 equals 2x. And if I divide by 2, it's the same as multiplying by 1/2. So 1/20 is my answer to this. You could also put it in your calculator and gotten the decimal of 0.05. Okay. In this case, we're going to condense into one log. So we get log 6, 9 times x plus 4 equals 3. Because remember, when we add logs, we're multiplying. So this is my base. If I write it exponential, 6 to the third equals 9 times x plus 4. 6 to the third is 216, equal to 9x plus 4. You can either distribute or divide both sides by 9. I'm going to divide by 9, and I'm going to get 24 equals x plus 4. And if I add 4 to both sides, or subtract 4 from both sides, I get x equals 20. So today we looked at solving log and exponential equations and using the fact that they're inverses to solve those difficult equations. So have a math-tastic day.